Welcome everyone. I'm Isabel, and today we're going to talk about APIs. And I'm sure you're all aware that there is, I hope you're all aware that there is another top 10 list, which is an API specific one. And we'll get to the nuts of that and give you some recommendations on hopefully avoid those, right? So sorry, here we go. So, it's not going to be a surprise to you that API breach is on the rise. There's a website that at 42Crunch, we have an API security platform. We also do a lot of community education, and we have a specific dedicated site called apisecurity.io. You may have heard about. This is a completely non-marketing and it's just pure education and collaboration and community. And in there, we very regularly report on breaches and recommendations, etc. If we look at the last 2 years, 3 years, we've been reporting this. We'll see that a lot of the problems are, coming from a recurring combination of problems, right? And things that we know about, like we've been told about this. We know that there are things that we have to do. We have to validate inputs and do rate limiting and manage our data. And this is all we're going to talk about now. And very recently, so this is really a report I encourage you to read. About a week ago, IBM published this new report saying that cloud breaches are actually linked in 60% of the cases to misconfigured APIs. So this is really a pervasive problem, right? So why is this happening? So there's multiple issues that we have to take in account here. And the first one is, well, we're humans. And as humans, we make human errors, right? And that's why you hear me say a lot about automation and scaling and how we can avoid being so prone to basically human errors. What can you do about that? So that's the first problem. The second one is we still consider security way too late in the API lifecycle. So we'll just, create our code, those APIs, we'll just make them work, make sure they're functionally okay. And then when we're happy with the time that's left there to take care about security. And with the problems we have on security today, that simply cannot work anymore. We really have to consider security way earlier in the life cycle of the APIs. What else? Well, if you're a developer on the call here on this webinar, you've been equipped with fantastic tools to be super productive. You click on the button, things get auto-compiled, local deployed, you have frameworks, you have IDEs, lots of tools, where your friends on the AppSec team are not that lucky. I think, first of all, there's a very few of them compared to the number of developers. Second, they don't have the tools that you have. They're not that efficient on APIs today. And frankly, they're really running after all those APIs that are popping up, like a customer of mine said the other day, like mushrooms all over my data center, right? So we create many APIs, we deploy them like 5 times a day, and that creates really many problems for the sec teams. And also importantly, what have API brought us? Well, they have changed the way we write applications fundamentally. So what we used to do server side in terms of controlling layer and management, now we have moved a lot of that logic and code on the client side, which means like all the controls and all the things we might be doing on our mobile apps or web apps or whatever it is has absolutely zero effect if I'm going straight into the API. All those controls are not there, right? And so we went a bit fast here in removing a lot of stuff on the server side and move it on the client side where really it's not engaged, it goes straight into the API. So that change of architecture is really a problem. And finally, and not least, security has changed really, right? And usually security was all about the perimeter. We were building walls around ourselves and a series of walls. With the hope that if we were, somebody was jumping over the first wall, there'd be a second one and a third one and a fourth one to actually stop them. But when you create APIs, what do? You punch holes in those walls, right? Every time I'm opening an API, what I'm doing is I'm opening an avenue into the data within my data center. That's why I try to represent with that picture here of the Arc de Triomphe in Paris. where every avenue comes into that. Every time I do an API, that's what I do. So this is not about boundaries and walls anymore. It's really about protecting the data. To recognize all of that, that's late 2019, this OWASP specific top 10 for APIs came up. To recognize that APIs are different, the architectures of our apps based on APIs are different, and are opening a whole set of new vulnerabilities. There's a bit of overlap between the traditional OWASP top 10 and this one, but really there's brand new problems that are linked to everything that I mentioned before, especially the data-centric characteristic of APIs, right? So as you see, there's common colors in there, orange, blue, and green. They're meant to kind of group the problems into like 3 main categories that I'm going to detail now. And the first one I'm going to talk about is data protection. But before I do that, I want to talk to you about one problem that for me is characteristic of what you really shouldn't do. So this is Parler. If you're in the US, you know what Parler is. It's known here in Europe. But basically, this is like a social network of a certain kind. And in January this year, this got attacked, and a lot of data, 70 terabytes of data got leaked, right? And this is probably the only problem that I know of that has 6, only for that specific vulnerability and set of problems, 6 of the 10 problems, right? And the core issues, we'll get a bit more in details of those, but the core issues were 0 authentication, so like free access into the API. Again, it's control at the client level, not at the API level. So 0 authentication once you know the endpoint, which is easy. No rate limiting at all. You can, it's open buffet. You can go and call it as much as you want. Sequential IDs, we'll get back to this to understand why this is critical, but basically allows me to have a little engine that retrieves data. A lot of metadata has been leaked in there. So this is like extra exposure of information around leaking PII and specific like the location of the people who have done some posts on that social network. And last but not least, and this is another interesting problem, is when you were going to delete your post, which a lot of people did because of the political events in the US at the time, and the data was really not deleted. It was just a flag that was turned on in the backend so that when the data was returned to the UI, if that flag was on, it would be shown on the UI, but the data was still there. So if you go again straight into the API, all the data is there. So all those people that thought they had deleted some data, they really didn't delete the data, right? So good example of what you must not do, and we'll get into the details now. The first one is data protection. So there's a lot of things in APIs that is very specific about data. And there are basically 3 things. Well, injection, you all know, this is very, it's still there. It's not in the top 3, of problems for APIs, but it's still a problem. Like anything related to injections is still there. But there's 2 new things which are related to A, what is the data we return through our APIs, and B, what is the data that we accept through our APIs, right? And how much we need to very much control that information. So let's talk about what we should be doing here. And you will see this is all very much common sense, right? So this is not be new to any of you, right? We've told you that for the past 20 years at OWASP, I think. You have to validate data that comes to you, right? You cannot just accept data that comes to you without first validating it. So we don't consume data before we validate it. And that applies everywhere. So first rule of security, no trust. Doesn't matter if it's external APIs, internal APIs, if this east-west traffic because you're using a service mesh. So inter-services communication. Don't make exceptions, because if you make exceptions, they will stay. That will be a technical debt that will bite you later. So by as a rule, everything that comes to you, you have to validate. If you're doing some validation on client side, that's cool, probably for UX and for your consumers of those applications. But the validation must happen server side. Remember, I can bypass the client and go straight into the API. So any validation doesn't matter. It has to happen on server side, right? What are the core problems around this we see across all those things I was saying that we have reported in the past 3 years. Two things. A, we're kind of taking the data blindly, we're not validating it, and we'll just take it, maybe a JSON structure, and boom, we push this into a database without even looking, right? So we really have to very much validate what is this request that comes my way, what does it want to do, okay? And in general, we also, just to make it easier, have the same data structures for the reads and the updates. So we have some data, we want to, push that into a database. All the data we return, the updates and the reads most likely need different A, operation, B, maybe smaller data structures. Again, it's all about control, right? So validating the inputs, where do I do this? It can be in my code, it can be in my API gateways if I'm using API management. It can be in, a new category of products emerging like ours, which is an API firewall. So something that specifically will validate data for APIs, right? But in general, the rule should be the earlier you detect such problem, the better. What I mean by that is, and my flow of data coming my way, the earlier in that transaction, I can keep at bay the things that I don't want, the better. Don't let things all the way back to the core of your data center before you decide, oh no, this is not something I want to accept, right? We should detect that way earlier. So that should be, pretty normal. We've told you this. You have to do it for APIs or any kind of apps. Maybe what we haven't told you yet is, oh, wait a minute, there's something new in APIs, and it's called JSON Web Tokens. Maybe you're all using that for authentication, for example, authorization or any kind of transport of data. This has data inside, right? So we have to validate those as well. There are plenty of emerging threats around injecting data through the JSON headers, JSON Web Tokens headers, through the payload, which is really a payload. This is just data coming your way. Whichever data coming your way, wherever it comes from, however it's packaged, you have to validate it, right? So this also applies to JWTs if you're actually using them. And the other thing we have focused so much on traditionally is validating outputs. So this is number 3. This is this API 3 in our list, is controlling what is the data that I'm actually exposing to the outside world. Again, one of the key things we have done when we moved from a traditional architecture to an API-based architecture is moving that filtering and validation that we were doing on the server side to say, oh, to this client, I'm going to show 3 properties, and to that client, I'm going to show 10 properties. We move that on the client side, which basically means if I go straight to the API again, I don't see 3 properties, I see 10 or 25 or 100, I don't know, right? But we really must not even, right, do any filtering, especially if data is sensitive or anything, on the client. That needs to happen server side. We need to offer endpoints with the data that people need from the server side, not from the client side, right? So I mean, you need to take control over your data, JSON, XML, whatever it is, right? So that you really control what you're going to show to who, depending on who they are, etc., right? And of course, nothing sensitive, no tokens, nothing like that. In API responses, watch for exceptions, for example, not leaking exceptions. And by the way, this also applies to headers. We're giving a hell of information in headers in responses, like what is this application written with? Why do I care? I don't know if I don't care, but hackers do, right? You don't want to say any of that. That's useless. Which product is being used behind the scenes. I don't want to do that either. If I have that information, I can take it and I can go on the CVE database and find if there is a known exploit for that specific server or framework. So don't tell me anything about the internals of your application through headers. That's part of that, okay? So that's data. This is all about controlling what is the information we expose and what is the information we let in, okay? Now, next problem is authentication. So broken authentication, as you can imagine, well, I don't have authentication. I can go and connect to something I should not be able to connect to because I've not been authenticated or I don't have the proper information to get there, right? My view is I don't see any, well, maybe there's some exceptions, but very, very few exceptions in which we have an open API that anyone can consume with zero authentication. And that applies to internal APIs as well. It's not because it's internal and it needs to be open bar, right? Because, well, you have a lot of internal problems to start with. There's a lot of problems which are coming from internal attacks and not external attacks. Again, back to what I said about data, no trust. Sorry, that's the way it is. So we have to close things down, right? You have to define, what do I want? I was talking to somebody the other day, everything they do is basic auth based, which is like scary, frankly, right? And the same user password for everything, which is even more scary, right? So do we need that? Is that okay? Maybe we have a problem. Is it an API key? Is it OpenID Connect? Whatever it is, you will have to go and define that based on the risk, again, of that API, right? But if you do something, make sure that those tokens, whatever you have, are short-lived. So if somebody steals it, if it's getting lost for whatever reason, you cannot use it for a year. B, you cannot access all your APIs and all the endpoints and everything with one single key, right? So be careful about this. You also have to really educate yourselves. This is like 3 hours of presentation by itself on OAuth and grant types. Right? And there's a lot of confusion around this. I see this all the time. We have a lot of education by people like Philippe Deric, who is also a speaker in this session and in this event on, what is OAuth, how does it work? Super educational. Follow this, go and understand what are the implications of the decision that you're making, right? And again, back to my JWTs, my JSON Web Tokens. It is not enough to just validate that a JSON Web Token is properly signed and that signature is valid. That's just like 5% of what you do to properly validate a JSON Web Token. So there is, hopefully, as there is for anything, there is an RFC to actually explain that. Go read it, check your libraries, check your auth providers, what are the validations they are doing, and make sure you're properly doing that, right? And finally, again, the number one repository for API keys today is GitHub, because we hard code this in the code. So they have a bunch of now secret scanning and make sure you engage that. So if somebody in your organization is pushing some code that has hard coded secrets, it will actually automatically detect it. This is really, really important, right? And again, you have to test this. Say this on every single page. Every single problem that is potentially a vulnerability, you have to test for, right? And same applies to authorization. And in authorization, we're going to find API 1, which is like the number one, as you know, right? Those are ranked by the order of importance and criticality, right? That order in the top 10 is not innocent. So API 1 is really critical. So what is this about, right? API 1, you may have heard this as IDOR previously. The people who were creating the API top 10 decided to rename it to BOLA, for Broken Open Object Level Access, right? Just to make sure we all understood that this is an authorization problem. It is not really, that's the core of it. So the core of the typical problem will be this, right? I'm Isabel, I'm authenticated to the system, and I'm trying to call get account details with account 123, okay? Now, I must not be able to do get account details 345, right? Which is another account number, because that account number is not mine, it's from a different person. So this is definitely really an authorization problem. We need to be able to, when we get that call, define that, Isabel, nothing to do with that account, only 123 is good for her. Right. So the other thing is a lot of confusion there about the fact that I can use all scopes for that, which are really about an operation and not a resource. This is access to that specific 123 or 345 resource, the resource identified by that ID, right? So that's the true fix. And sometimes, after the fact, putting in place all those controls is really difficult. So the thing that makes BOLA number one is two things. A, that we tend to use guessable IDs, like 123, 124, 125, right? And in here, really what you should be using is UIDs, like a 36 character long, something people cannot guess or iterate over. That's really the key thing. And this is mitigation. That's not a fix, but it's a good mitigation. And if you have been exposing internal IDs all the way back to clients, right, somewhere along that flow, you should really map those internal IDs to something which is not what the real ID on the backend database is, right? So don't expose this all the way back to the consumers, right? So that's one of the key recommendations. And the second one is really about rate limiting, which is really what happened at Parler. So you have sequential IDs and you have no rate limiting. And this is like a recipe for disaster. Because what that means is I can write a little engine that iterates, because they're guessable, over my IDs. And I can just do this as much as I please because there is no rate limiting to stop me or slow me down, or even to raise a big flag somewhere in a monitoring window that says, oops, something is going wrong here because we have this huge number of requests on get access details, which is really out of the ordinary. So at least you detect the thing so you can actually stop it even, and then fix the problem, right? And again, if you want to detect this thing, you will have to test it, right? So this is, again, something that you need to put in continuous testing, right? So that's at the resource level. And API 5, it's at the operation level. So this is all about, I'm allowed as Isabel to do get account details, but I cannot do post account, right? And also we tend to expose in the same API operations that really should not be mixed in the same thing, like admin and non-admin operations. Very easy to find those through dictionary attacks. We're not very good at inventing crazy names when it comes for API names. So we'll probably have something for admin. We're going to call it /admin, most likely, right? And then, /admin users or /admin accounts or whatever it is. So it's very easy to do so, right? So if you have some admin stuff, just, isolate it, restrict it by something which is more complicated, like mutual TLS, or, allow it from certain people only, whatever it is, but just isolate that so that Joe Doe who's using your API will actually cannot find and use this, right? And again, don't rely on the client apps to do this. Like, don't have a flag in your UI that says this is admin, non-admin. Again, if I go straight into the API, you're not going to block me, right? And in general, what you really want to do here is really control the verbs and operations that your API allows. So if somebody, whenever I do a demo of our platform, I pop up 1 hour firewalls, maybe half an hour, 1 hour before the demo. And, every single time, by the time I do the demo, our dashboards are populated by bots calls and people just finding that a new IP address up and just boom, you have some bots there trying to guess what that API might be. All right, so you have to really block this out of the way. So those bots will be blocked, and then you're sure you're not accepting anything else but what you actually want, right? So again, you have to design this properly. You have to know what your rules are, what are the permissions, and you have to test this again. So here, yes, the scopes in OAuth, if you're using that, can help, because this is where I can say, depending on how I obtain the token, and that token is valid for scope, read account, but it's not valid for scope post account, then even if I have a valid token, I will not be able to call that operation. So you'll be able to do it there. And the last thing I wanted to talk about is logging. So there's a few more things in the API top 10, which are more traditional, I would say. So it's easy for you to find some information about this, right? But logging, as we'll see, is really critical, and secure logging in parallel, in particular. And I'm insisting on this because at many customers and places, we see that people don't have the information to actually even know what the heck is going on in the system, or what has happened, right? And then being able to find where the flaw is and fix it, right? So this is great for, and critical for forensics if something happens. It's also great for non-repudiation from a security perspective, right? So what we want to do here is to log anything unusual, and we want to log it at the lowest, at production logging level, not at debug level, right? Because we're going to have this in production, And everything that happens in production, we want to have any unusual event being logged somewhere. And we need to know what happened, when it was, any information to identify the caller, where it happened, like, the machine or the pod name, if this is Kubernetes, whatever it is. As much information as possible to be able to trace back also the flow within your system, right? And really, this is something that if you have to think about it once the code is written, that's going to be a nightmare. If you don't do it now, this is going to be a technical debt. And it's going to be something that you will never free any time to do unless you do it as you write your API or your application. Adding security, secured logging, whatever after the fact, it's very easy. It won't happen. Now, if you're, in a large company, you're not just use frameworks to actually do this. Give your developers something that they just have to write one line in the code, and it's being pushed in the right place, it's being consumed, they don't have to worry about this. So make it as easy as possible, like one line, and I have all the information, right? Now, what do we log? Well, careful with what we log. No PII, no tokens, no anything sensitive to your business, whatever it is, right? And if you have some sensitive data, such as tokens and IPs, then ideally you want to hash those, because then you can also kind of track that information. Like you can see that token that came in from multiple differences. If you hash them, if you redact it, then that will not be that useful. You'll have X's to track. That's not going to be very easy, right? You may have to encrypt it. And then only a few people within your company will be able to actually get that information. You may have to sign those logs, depending on your industry, for non-repudiation purposes, right? And linked to that, because I see this a lot at customers as well, the implications of passing data as a query parameter. So you really have to be careful here that whenever you pass something in a query parameter, it's going to end up in log somewhere. It's going to be pushed somewhere in the log manager, then go up in dashboard. So don't do this. Never pass any sensitive information on the URL. Right? It's always in the header, or in the body in the post, but it's not in a query parameter ever. Okay. And finally, this is dear to my heart because it's one of the roots of why we created our company, right? Is I really would like to change for people to become more proactive about security and not so much reactive. And the reason for that is design decisions, whatever you decide for your app or your APIs at design time, that's really hard to do, if not impossible, because again, you're going to be caught into technical depth that you will never have the time to actually catch up on, right? So in an API world, what do we have to do? We're going to take some decisions when we design, when we define the API, when we design the interface of the API, when we decide how we're going to operate the API. And all of these have direct links into those API top 10 that I had mentioned. Defining what the data is, who's going to consume it, how we're going to access it, the data structures on request and response, where the admin is going to be, how we're going to operate it, where is define the rate limiting, design a rate limiting. You have to design rate limiting. Manage versions, how we're going to retire things so we don't leave it there open and forget about it. So all of this should be really, for me, the call to action would be to use the top 10 and all the information we have around that as a framework for designing and testing your APIs, right? Again, if you worry about security so late in the life cycle, whatever problem is being introduced is going to be super expensive to fix, if it's even possible to fix without rewriting the entire thing, right? So the earlier we talk about this, the earlier we design it, the better we're going to be at building secured APIs. And then we have to really think about, think differently, think like the hackers. So what we usually at developer, what we do is we want the thing to work, right? So we do functional testing. But for every functional test, you should have 10 what I call negative tests. You have to hammer your API with all kind of bad stuff, expired tokens, sending a string when it expects an integer, sending users that don't exist. The only way you're going to test that your API is resilient is if you automate the testing of that API with all kind of bad stuff. And you do this continuously, right? And that's my last point, and maybe the most important one. We have to automate. You have to define those best practices, those design rules, those runtime rules, those tests, and don't rely on any manual testing as much as possible for the security team and also for the developers, right? Because that's the only way we're going to scale and avoid those human errors we've talked at the beginning, whereby we're gonna introduce errors because we're human, right? But the key thing is to catch those errors, and we want to catch them as early as possible in the life cycle. So define processes and automate them iteratively. That's a lot of work, I know, but start small and do this along the life cycle, and you will see our API's quality and the API's security is going to improve tenfold. And this concludes my presentation. I will let our host here talk about the Slack channel. But as I said, we have this API Secure.io. Please join us, and hopefully the information you'll find there will be useful to you.
Okay, thank you very much, Isabel, for great talk.